Alright, so what is limits of accuracy? So limits accuracy will tell you the upper and lower boundaries are for the true measurement. Okay, it's hard to understand, but give your example. I will draw a ruler here. I have a ruler, let's say, like it's not to scale, but let's say that's 1, 2, 3, 4, 0, 1, 2, 3, 4, 4 centimeters. Okay, that's 4 centimeters. And then you know on your ruler you have millimeters as your smallest measurement units, right? Like the millimeters, the lowest measurement units. Well, 1, 2, 3, 4, 5, 6, 7, 8. Well, let's say that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so like I know it's not to scale, but like that's similar to a ruler. And then what I will do is I will draw an object. Okay, I put the left hand side at 0. Okay, this part is 2.2 centimeters. Okay, this is the actual. Okay, can you see like it's not really to scale, but actually is an object start from 0, finish at about 2.2 milliliters. Like when you read the ruler, you say that's a 2.2 centimeter thing. But let's say see the actual length. I'll draw a line vertical down here. Okay, can you see it's not really reaching 2.2? Can you see it's not really reaching the 2.2 value? But what you will say, when I ask you to measure this, you tell me that's 2.2 centimeters. You're not going to tell me that's 2.18 because you can't really measure what's like, that's a 0.8 millimeters or a 0.9 millimeters. You can't really read that clearly on your ruler. So that's the limit of accuracy. You tell me a 2.2, but actually the objects maybe is a little bit less than 2.2, or maybe it's a little bit over 2.2. Okay, it's hard to tell. It's hard to tell. You can't really measure something. The smallest units you have is 0.1 centimeter. So when you give me your answer, it will be 0.1 centimeter. That measurement tool already restrict the answer you can give me. You can only give me to 0.1 centimeters. So therefore, our limits of accuracy for these objects, I'll say the smallest units is 0.1 centimeter. Okay, the lowest like measurement units is 0.1 centimeter. So what you can't read will be 0.5 to the left and 0.5 to the right from the smallest units. Because like say, if this is about in the middle of 2.1, 2.2, you will say maybe that's 2.1 or maybe that's 2.2. Or if you go a little bit to the right hand side, you can still say, well, if the object is here, okay, a little bit over 2.2, you can still tell me that's 2.2. So you have a range of values, so which is the 0.1 times 0.5. Well, the boundary is between the smallest units times 0.5. So you can see that is 0.05 centimeters. Okay, that's 0.05 centimeters. So from your actual, like the value you read, you can go left by this much and you can go right by this much. That's the actual length of this object. I don't know because I can't measure. I don't have a smaller than this. I don't have a really accurate thing to measure it. So I can only give you a range of the length. So that's the smallest units times by 0.5. And from your actual measurement value, you go left by this much and you go right by this much. And the range will be the boundary. And that's called the limits of accuracy. So in this case, that's the 2.2 minus 0.05, that give you 2.15 centimeters, and then I have 2.2 plus 0.05, that give me 2.25 centimeters. So therefore actual objects will be in between that range. Okay, this x is the actual length of the objects that will be in between that range. You say it might be 2.18, it might be 2.19, I can't tell. But the best answer I can give you, it is 2.2. Okay, the best answer I can give you is 2.2 because my ruler, the smallest units can give me is 0.1 centimeter. So I read it's very close to 2.2 centimeters. Therefore, my answer will just be 2.2 centimeters. Yes, does that make sense? So let's have a look at the exercise. Okay. Another thing is 6 centimeter and 6.0 centimeter. Do you think they're the same thing? Yes? But why there's a 0.0?
0 something.
0.0 something? Yes, it must be 0.0 something. This is the difference between those. Well, they are like something 6 centimeters long, but the actual smallest units you can measure is different. Like the accuracy is different from those two answers. From the first answer, your smallest units is 1 centimeter. Okay, you have a maybe not ruler. So it's something only got 1 centimeter, 2 centimeters, 3 centimeter. You measure that, you say, it's very close to 6. Maybe it's 6.3. You don't know because you don't have the 0.1 centimeter. So you will answer, okay, this thing from my measurement, from my accuracy that I can have is 6 centimeters. But for the 6.0, you can really have a look. Okay, you got, that's a ruler, for example. You have the 0.1 centimeter and you read, that's 6 something but not reach 0.1 yet and not less than 5.9 as well. So your limits of accuracy gives you 1 more decimals compared to that one. It's more accurate measurement. So if you think about the boundaries, this smallest unit will be 1 centimeter times by 0.5. That gives you 0.5 centimeter. So the actual range of this object came from 5.5 to 6.5 centimeter. Okay, so it's a wider range. So for the 6.01, so 0.1 centimeter is the lowest measurement unit. So you can see from that I have 0.1 centimeter. So the lowest measurement unit is 0.1 centimeter. That times by 0.5, you have 0.05 centimeter. It's more accurate. Okay, there's not much errors when you calculate that. So that's 5.95 centimeters to 6.05 centimeters. Is restricted to a smaller range. From your answer, I can see what is actually your smallest measurement units. From the 6.0, because you can give me to 1 decimal places, you must have the measurement tool got 0.1 centimeters. So 0.1 centimeter will be my lowest measurement units. So I'll use my lowest measurement units times 0.1. That's the value you can like go up and go down. So for the first one, you can go up or go down by 0.5 centimeter, which is quite large. But for the second one, you can only go left to right by 0.05 centimeter. That's very different. Okay, so from the length, 6.0 and 6 are the same value, but the actual meaning are different. Okay, the accuracy is different. This is a very helpful tool in chemistry and physics. I think in the science subject, we don't really use that a lot in maths. It's more for helping the chemistry, like when you measure things in the tube and how you read it, what's the smallest decimals you have. Okay, so it's a helpful tool for science subject. Please don't eat in the classroom. Can't eat in. But like you shouldn't eat during the class while others studying. Whether you eat outside or later wait for the lunch. Okay. Okay, exercise. James measures each side of a square as 6 centimeters. So the smallest unit we consider is 1 centimeters. We don't have a ruler. We may just have something to measure. There's only 1 centimeter, 2 centimeters, 3 centimeters. So the smallest units we have is 1 centimeter. So find the upper and lower limits for the size of the square. So we have a square, but we measure 6. It's not actually 6. Maybe it's not actually 6. So we draw a square here. We say each side is 6 centimeters. But as I said from this example, from the left-hand side example, so the lower and upper, the upper boundary will be 6.5 centimeter and the lower boundary will be 5.5 centimeter. Okay, it's different. Okay, it's different. That's the why I got 5.5, because the lowest measurement units is 1 centimeter. 1 centimeter times 0.5, I got 0.5 centimeter. I can go up and go down by that much. So 6 go down by that much is 5.5 and go up by 0.5 is 6.5. So the maximum I may have maybe 6.5 centimeters for the square, or 5.5 is my lowest possible values. I don't know. Okay, so this is just something I may have. I don't know the exact value. So B is asking the upper and lower limits for the perimeter. So the P lower will just be 5.5 times 4, because the lowest possible value for the square is 5.5 centimeters. So the lowest possible perimeter will just be 5.5 times by 4. Give me the perimeter. So 22 centimeters. So the upper one will just be the highest possible length I will have times that by 4. So 26 centimeter is the highest possible perimeter I may have. So it's all coming from your measurement. Okay, so you measure something at 6 centimeters, but it may not be 6, can be 0.5 to 6.5. Therefore, your perimeter will change accordingly to the actual value of the length. So asking for the limits of the square, for the area of the limits of the square. So the area for the lower area we can have is 5.5 squared. And then the area of the upper bound will be 6.5 squared. Okay, so lowest possible length times itself, highest possible length times itself, that give you the lower and upper area. So all of this answer should come from your measurement. Okay, it should come from your measurement. Just emphasize that again. If you have something measured at 6.00 centimeter, 6.00 centimeter, your lowest measurement units will be 0.01 centimeter. And the value can go up and down, will be this times by 0.5. You have 0.005 centimeter. And you use 6.00 minus this, and 6.00 plus this to have the lower and upper boundary. So it's how many decimals you have. That's giving you the accuracy. Okay? Alright. If you have no questions, we have finished this chapter 6 measurement. And you, yes, Michaela?
Is this on the test?
This one?
Yeah.
Well, it's very hard to be tested, but like it's a good knowledge you need to know.